people tell me, like, I talked to someone yesterday, like, should I still learn to code? Like, is that going to be a waste in 5-10 years? And I'm like, knowing how to design systems is going to be really, really important. And like they talk about, like, programming is building a theory, like, and building a theory and designing this stuff, I think is really, really important.
One of the biggest improvements I made was just switching to Gemini Flash. You can see I tried GPT-4o, then Sonnet, and then Gemini 2.5 Flash. And you can see the difference it made just right there.
There's tons of data of cars driving perfectly fine on a nice sunny day on empty highways. That data is completely useless to every self-driving car company out in the world. What I want to see is a car carrying 3 other cars on a tow truck that looks like a car headed towards your direction with a median that's completely in the middle of the road because it's broken. That is useful data.
And the goal with this is to say, like, okay, how can we build a pipeline that takes all these different kinds of receipts and extracts the information from the receipts, such as the item amounts, the grand totals, and everything like that.
Oh, wow. Here we are again. AI that works. What's up, guys? How y'all doing?
How's it going, Dexter?
I'm doing great. I'm currently in an undisclosed location taking care of some business, but I wasn't going to miss the pod because I'm very excited about the topic today.
Where the heck are you?
I am in an undisclosed location. I'm in a very colorful conference room.
It looks like you're in a Willy Wonka factory, if I'm completely honest.
You're not far off.
Well, guys, good to see you again. I think today's episode is one that I think, funnily enough, I had a few DMs this week just talking purely about multimodal evals. And I was like going straight forward. I was like, oh my God, this is a perfect episode for the timing of what's going on. And then Kevin here, who many of you might have seen from a previous eval episode that we did, had actually gone through and gone really deep into this problem. And I was like, well, there's no one else better to have than Kevin right now on this timing.
Well, I appreciate that. And yeah, introduction for me, like I was on the podcast, a month and a half, hard to remember, lose track of time. But on a previous large scale classification pipeline evals. But Kevin Gregory, I work an ML engineer at Evolution IQ, and we build claims guidance software for insurance companies. Hopefully we build AI that works.
Yeah. I mean, when you're in, and that's a thing I think that is like, we don't talk about enough on the show is like, Vibeoff spends a lot of time, and we try to bring on guests who are working in industries. It's a lot of like, things that you can apply in like vertical AI. One of the things that led to like the whole 12-factor agents thing and the context engineering thing at the start was like, hey, like, let's go talk to a bunch of people who are actually like shipping real AI products to the enterprise with high reliability in situations where like, oh, it doesn't work. Like, let's blame the AI is like not an acceptable excuse. Like, it has to work. It has to work almost as good as deterministic software.
I mean, if it doesn't, it's just not interesting.
Exactly. What's the hard problem, right? What's the thing that a lot of people may want to just like nope out on? And how are people who need to solve real problems for serious businesses actually like putting pen to paper and solving this stuff?
And multimodal eval is something that we do a lot at Evolution IQ because there's a lot of medical documents that come in with insurance claims. And you can OCR it and get text and just kind of treat it as a text input, or you can just do multimodal. But how do you do that? How do you build it reliably? Which do you choose? There's all sorts of considerations that go into making those decisions and building out those pipelines.
So with that in mind, I think what we should do first is let's just lay out the problem that we're working on for everyone, so that way we can have it understood. So I'll screen share. I'll show off the Excalibur. And Kevin, why don't you just take us through and start posting some like general diagram of like the problem that we're investigating here together?
Sure. So you just want me to start drawing an Excalibur?
Yeah.
Or if you want to talk through it, I can try to take notes if you want to do like the broad strokes, and I can annotate it.
Yeah. So many people on this call may be familiar with something called the cord data set, but what it is it's receipt data. And the goal with this is to say, like, okay, how can we build a pipeline that takes all these different kinds of receipts and extracts the information from the receipts, such as the item amounts, the grand totals, and everything like that, and does so in a reliable fashion. And what's interesting about receipt data is that there's a lot of, for one, the actual size of the data or the size of the images are kind of all over the place, right? Like receipts are, everyone I think here has probably been to CVS and gotten the receipt that's like 30 feet long, and it's kind of comical. And things like that are not at all what the LLMs are expecting, right? They're expecting kind of a certain specific size and dimensionality, and so
Do you
receipts.
want to post some of the images here just so we know what we're looking at?
Absolutely. Look, so these were actually, interestingly enough, from Indonesia. So these are Indonesian receipts.
Okay.
Yeah. Oh wow. Look at that. So it took me a minute to figure out like why the commas and decimals were different. And it's because it's Indonesian. And you can see there's the kind of a normal length one there, and here is a really small one with only one item. And I'm just scrolling through and randomly picking them, so I'm not kind of,
And interesting. So they're like, not only are they receipt data, it's like receipt data that's like randomly blurred or like hidden away too.
Mm-hmm.
This is like redacted for privacy or what?
I suppose for privacy, not a lot of vendor information here per se. It really focuses on the totals themselves. This is just the data set. This is from Hugging. It's a Hugging Face data set.
Got it.
Yeah, I mean, I can just.
I can see how this is not only this silly, it's like comically silly in the form of like CVS. Is like in that scenario, you can't even see, you can barely see the total if you really squint, and you can make out some pixels of what it might be.
I put this one in. I don't know if this probably is not actually part of the data set because you cannot see the actual totals.
I mean, if you squint that anyway. But I think the point here is like, and some of them are like grease stains, some of them are clearly have shadows and all sorts of other problems on them.
There's some that are crinkled at different angles.
Yep.
So
cool. So like really real world data is what I'm seeing.
Mm-hmm. Yeah. And it's another thing that's interesting is and we'll kind of get into this when we start exploring and kind of discovering the things I did and the mistakes I made and what I found is it seems like some of the restaurants randomly have different taxes that they apply, and those can appear in different ways and don't always get added to the total. It looks like see this PB1. You see this in this purplish one right here that I'm kind of moving around. Yeah, this PB1 is a restaurant tax that is only there sometimes. And so
it's not even added to the total, you said?
Sometimes it is, sometimes it's not. You can tell here it is because it's the only one that ends in a 2 and the total ends in a 2.
Oh, yes.
But it seems like sometimes it's there, sometimes it's not there. I also discovered that sometimes there are just discounts applied. So it's a kind of thing where the more you look at these, the more challenges you find. And that's kind of the point, right? Is you have to just start building the system and build a system in such a way where it allows you to easily and quickly uncover these things.
Okay, so what does your output data set look like? Like I'm wondering, like, do you have a table model? Are some of these fields optional? Like, what do you actually want in your structured outputs here?
Sure.
You said item amounts, grand totals. Like, do you have either a document or a BAML struct or something that kind of just demonstrates all of the things we might want to pull out of one of these?
Yeah, I've got a BAML file, and I can just post quickly.
Yeah, just put screenshots in here for now. We'll get to the code in a fact, and we'll go dig into it later.
Yeah.
Well, or even extracted JSONs. If you have like extracted JSONs, they might be interesting as well to just take a look at really quickly. Just so we can understand what the final end output is.
So this is the BAML class. And this is of the final, right? Initially, I didn't have the unit discount or the rounding or things like that in there. You'll kind of see me discover these things.
Rounding. Interesting. Okay.
Yeah, interesting, right? Yeah.
I think this is, just looking at this, like my first gut instinct is just like my first gut instinct is like, I'm surprised that you need quantity for things like receipt data like this. I can see why, but it's not how I buy most things. Sometimes I have quantities, but usually I just say like what it is. Unit discount is interesting that you needed that in there. Like this thing obviously flags me in a very weird way. The fact that you need this is really interesting. Um, I really wonder why you call this grand total instead of total, but I can see why you have subtotal. It sounds like you
That's
have
it.
it just like
Subtotal. Yeah.
go ahead.
Subtotal versus grand total. I wanted the LLM to be really clear on what that those are two distinct fields and don't get them confused.
I see, and like we can look at this and we can clearly see that and it seems to be working mostly correctly.
Yeah. It's good. And there's some edge cases where that you'll see that that when I look at the receipt, I can't even figure out like what is going on in this receipt. The numbers don't seem to add up. So it's very interesting. It's very interesting.
Okay. So before we go into this and really ask us, okay, so someone asked a question, dumb question. Why did rounding stand out immediately? Well, the reason rounding stood out to me immediately is like, when I think of receipts, I don't think of rounding my totals. I usually just swipe my credit card and the number is what it is. So at least living in America, we generally don't round stuff. You might round stuff for tip and tax.
Gas stations have fractions of a penny.
Yeah, gas station, I guess. Okay, but that's rare.
Or they used to. Maybe they don't anymore. Actually, maybe that's like maybe I'm aging myself.
And then, so it just stood out as something weird that I would pull out because it's just not my gut instinct doesn't say that I would round by default.
Right.
And then another question that someone asks is, why not do OCR and pass to an LLM? I think for that we have a really maybe we should just do OCR really quickly on all these images, and just to show what OCR does. And at least Kevin, I'm not sure about your take on this, or Dexter, but my problem with OCR that I have always seen is OCR loses structural semblance.
Yes.
Whenever I do that, so like in the case of this thing up here, in the first image on the top right over here, if I were to do OCR, I would get a 1 and LM dumpling chili SC and 68, 000.
Without the spacing.
Yeah, I don't know. I would have to infer the spacing. I'd have to be like, oh, they're rotationally in the same angle, so therefore it's correct. But if the image was taken at like a slight angle like this, all of a sudden I can't even use OCR to be like, I have to go find like the normals of the image, and that's just a more complicated problem in my experience.
Yeah. Okay. So I think probably for the rest of this episode, like before we get to the code, I think it'll be really interesting to maybe Vaibhav very briefly recap just like the 4 or 5 categories of evals we talked about in the last eval episode of like runtime guardrails, Vibe evals, like deterministic evals, this kind of stuff. And then talk about, Kevin, just really high level, the architecture of your pipeline. And then we can get into like, what checks did you put at what parts and how is it implemented? How's that sound?
Dex, I love that you're asking me to do this, but Kevin showed me a screenshot of his dashboard. I think you should just pull that up. It's going to answer
All right, start there
really quickly. Let's just start with the final dashboard that we ended up with, Kevin.
The final one?
The final one. And I think we can start with what we ended up with, and then we can walk up to the journey of how we got there.
Sure.
And like what was the process of discovery. Because I think there was something that stuck out to me that when you DM me is like, I think one of the things that Kevin told me about this is like, this problem was way easier than I thought.
It was a lot easier than I expected. Yeah.
And
awesome.
First, like for people that were asking my handwritten documents or anything else along that lines, like this problem is way easier than you think. But I think the key takeaway here that we had when Kevin and I were talking about this was it was only easy because the mechanism that Kevin used to break down the problem is what made it easy.
Okay, so the design of the system mapped nicely onto the design of the evals because we had all of that in mind from the start.
Exactly.
Yeah. And I took a very similar approach to this that I took to the large-scale classification pipeline, right? Of what information is going to inform how you change the pipeline, right? Like what information is going to tell you where the errors are, what they are, and show you exactly what's going on, and then how do you display that in a way that just knocks you over the head with how obvious it is what's going on, right? So this is the final one. Vaibhav, I ended up doing 350 receipts total instead of the 100 I showed you yesterday. just to kind of fill it out a little bit more. And you can see here, right? These are the evals. Data completeness, are there receipts and grand total. Grand total calculation does the subtotal. I mean, so these two, grand total calculation, subtotal consistency, and sum validation, are just looking at different pieces of, if you add up just the transactions, does it equal the subtotal? If the extracted subtotal plus the taxes and rounding, does that equal the total? So just basic summations that are supposed to happen. Unit price accuracy, right? That is number of items purchased times the price should equal the amount extracted for that line item. And then positive values, right? If you're extracting something, it should be a positive value, right? You're paying for something, it should be positive.
And it's funny that there are negative failures there. That's actually what's very surprising to me.
Mm-hmm. Yeah. And so, I mean, what we can do real quick is we can just look to like, okay, so there are, two that fail the positive values. So it's extracting negative values somewhere. And that might be correct, right? The eval itself might be wrong, but we can just look at that. So let's see, if we go to the detailed results, we can quickly just scroll to, let's see, this one, a few failed. That's not the, so we can quickly just look to see where it failed with the positive. Here we go. This one had positive values. Or I'm sorry, this one failed the positive values. So we just look at the receipt. And so let's see, are there negative values here? No, there aren't, right? I'm not seeing any. No. Oh, the discount. It extracted a negative value for the discount. And it extracted that as a line item, not as a discount. Because if we go here, because we can see the extracted data right next to it, yeah, it thinks we purchased a DISC, and that it's not a discount on the amount, but we purchased something called a discount.
And what's funny here is that does lead you to having the right answer in the end.
It does, right? Because
you had 1 and -1 on the row.
That's right.
Yeah.
So because the summation all works, but it's interesting, yeah.
And what's really interesting here is if you had, for example, let's say you had built your software. Can you scroll up a little bit where you did the minus DSC?
Minus DSC
in the data set, in the extracted data.
Oh, in here.
Yeah. Like. What's funny here is like you could imagine someone saying, hey, unit price we know always has to be positive, and writing an absolute value on there. And like programmatically. And that would clearly lead to the wrong output here.
Mm-hmm.
Okay, so if you worked around that it had negatives by just flipping every negative to positive and assuming it was an LLM error, you would actually break the thing, because these two errors happen to cancel each other out. Probably like correctly structurally, like from whatever system this came from. But yeah, you make assumptions that nothing is ever negative, and you end up with okay.
Mm-hmm. And what's interesting here is like this is just like one of the failures here in terms of negative. But I suspect you're saying this, Kevin, because I suspect you spent a lot of time looking through the data, and every time it gave you something negative, you're like, oh shit, that's real world data. It's actually negative.
Yeah, exactly. So fascinating.
Question in the chat that I think is relevant. So none of these receipts have a golden data set, right? The Hugging Face data set doesn't actually have the right answers with it.
So the Hugging Face data set has, it does have what they call metadata. I looked at it some and compared it. It was, honestly, it just would have taken a lot longer to incorporate into the pipeline because it has a lot of quirks to it that I needed to spend a lot of time figuring out. And I think my goal with this was to try to build like in the real world, right? We don't have the golden data set. So how can we try to get closer to building that on their own was kind of the tack that I took with this. But yeah, Hugging Face does have what they call metadata, which has a lot of information, including the actual amounts.
My gut says that for most people working on AI pipelines, especially like multimodal data, they don't have a golden data set, like exactly what Kevin is saying. And I think if you go back to the original dashboard, Kevin, the homepage, instead of the detail view, my first gut says it's really important for people to be able to almost elevate from like having no golden data set and only random data to first building a proxy of like, is the system mostly working? And which evals are at the most risk of failure. So in this case, like we looked at positive values. Even though positive value is failing, it's actually not a true failure. It's a failure where if you look at it, it's actually correct. So we almost are like, okay, cool. Positive values are a thing we'll spot check, but they're almost always going to be correct. Now we can go look at sum validation or subtotal consistency or grand total consistency. And what's interesting to me is even if sum validation and subtotal consistency is wrong, grand total calculation seems to be way more correct. And being able to design from this and then slowly escalate to making a golden data set from this data is way more interesting than actually saying, let's go make a golden data set from day one, because it's just so much slower. By the way, how long
Do
did
you
this
have
take you timing wise,
This whole thing probably took me 3 or 4 hours.
including running everything, vibe coding the whole UI and everything?
Yeah. It was really fast. Maybe I'm exaggerating, but it was not a substantial time investment.
Interesting. That's actually way less than I expected, to be completely honest.
That's what I was saying when I meant that this is I want to say the stopwatch.
I mean, this is what we say about like code in general is like, I think someone was posting that like, oh, code is now really cheap and software is really cheap, and like update your priors about how and when and why you build software. And one of my favorite comments was like, the writing of the code was never the hard part. Like, it's important to get it right, but like when you have the design, and I know you demoed a similar dashboard to this, so like you kind of already knew what you wanted and you knew how the system would be designed and you knew what kind of data you needed like formatted on disk and you knew how you would run it. And it's like, that's the hard part that I think takes a lot of iteration and time. And like designing systems is still people tell me, like, I talked to someone yesterday, like, should I still learn to code? Like, is that going to be a waste in 5-10 years? And I'm like, knowing how to design systems is going to be really, really important. And like they talk about, like, programming is building a theory, like, and building a theory and designing this stuff, I think is really, really important. Yeah. I don't know, that's my take on like, yeah, this was fast because you knew exactly what you wanted and you knew what the design would be.
That's a good point.
And that stuff was hard earned. That stuff probably took months or years to develop.
Let's go back to day one. Like when you first started this project, Kevin, what was the first thing you did, and what did you end up doing next? Like, how did you end up in this final design in the very first one?
Sure. So the very first thing I did.
I'd love to know. Yeah. Okay. Sorry. Tell the story. I'd love to also know like a little bit more detail of like how it actually works. Like not every line of code, but like how do the different components of the system fit together, and like what are the interfaces that you created to make this work well for you and be kind of like be able to evolve it. But
sure.
All right. Let's go to baseline. Number 1, 21 receipts. Okay.
Yeah. So I started with just very basic like training wheels, right? Like I don't want to spend a lot of money on LLM compute if nothing's working. So this is using GPT 4.0. And right out of the gate, and you can see that the amounts it's okay, but there's a lot of mistakes, right? So the sum validation is the biggest one that we're missing. And if we look at that, we just can look at one of these. It's so interesting to me because it's so tempting to think that to forget that LLMs are just math and computers behind the scenes, and they're not actually people, because you'll just see flat hallucinations here that are just plainly wrong. I mean, I don't know one right off the top, but it's missing something here. You can tell it's off by a lot, right? 17,3,200. And if you would kind of scroll down the extraction here and the receipt, you'd find that there's just one that is just completely missing or just completely wrong. So my first thought was, okay, so what if I just use a smarter LLM, right? So instead of using GPT 4.0, what if I use...
Before you show the results of smarter LLM, question, did you have all these evals designed from minute one?
Yeah, I did. So my thought was, so if I'm extracting a receipt, and I'm getting things like the subtotals, I'm getting the item amounts, the grand totals. I actually went back and forth with it was Sonnet and Cursor and said, here's kind of what I'm doing. Like, let's brainstorm, figure out what some good runtime evals would be.
Okay, so the first thing you actually did wasn't actually do this. You just stopped and thought about the problem for a little bit.
So the first thing I did was look at the receipts. That's the very first thing I did. I downloaded the
Always
data,
look at your data.
looked at the receipts. That was and that's when I realized that hey, this is not American currency, right? We're somewhere else.
Okay.
So yes, the very first thing I did was looked at my data, just spent some time looking, just like we did with the whiteboard, right? Just looking at different receipts, and wow, there's all these kind of different things. Some are grease stains, some have some handwriting, some have random discounts. Well, I mean, I didn't see that right off the bat, but
Okay.
looked at the data.
What I love about the design of this so much is you didn't have to do any hand labeling. You needed no golden data set. You designed a system to evaluate the accuracy of extraction solely based on like the invariants that you know should be true about the receipt.
Exactly.
Okay. So you looked at the data. You literally, I'm guessing you just download data and just scroll through images and just like pick random ones and just like skim really fast.
That's it.
Okay. So step 1, looked at data.
Mm-hmm.
Step 2, what did you do next?
Step 2, I set up basically set up the project, set up the repo, set up BAML, and went back and forth with an LLM to figure out what runtime evals there should be.
So really quickly, what do you mean by set up the project? So you does that mean you started loading the image files? You started running a small test harness in Python where you could like loop through images really quickly, or was it purely just like initialize? Like
it was purely just initialize.
Okay,
purely
so
just
not
initialize.
Really anything, just so you could have a folder to work out of.
Exactly, so I got a folder to work out of.
Okay, and then I'm guessing you defined your receipt data model very very trivially.
Mm-hmm. Yeah. Define the receipt data model in BAML.
Okay, so the original one didn't have all of these like rounding.
Can you
grand
show
total,
roughly
tax
what
stuff.
the original receipt data model was? Do you have that somewhere?
No, I don't have it.
You can just write it. If you just want to write it really quickly, like to be like receipt V1, I'm just really curious what you ended up.
I mean, I can just kind of pretend here, right? So this is what it ended up being. So the initial one was literally just item name, quantity, unit price, total price. And then that was the transaction data. And then for the receipt data, all of this was gone. And I just had transactions, subtotal. No, I think I just had transactions in total initially. It was just add up all the transactions, that should equal the total.
Got it. Okay. And then you went through like a cursor conversation from here, and you said, what are some runtime evals that I can do?
And then that got me to update this so I had the subtotal and the tax, which made sense to me.
Got it. And that was like it didn't really like disagree with what you were thinking. It was like, this seems obvious. And the cursor conversation led you to have, and if you pull up again what evals you were showing, what the evals you had were data completeness, grand total calculation, unit price accuracy, subtotal consistency, positive values, and some validation.
Right.
And then that once it described those, you added subtotal and tax, and now you have a data model and then evals that you have.
Exactly.
Perfect. Cool. And then you ran that on a very cheap model. I guess the model that you're most familiar with, which is GPT-4o. I still like talking about cheap. It's just about familiarity. It's just like the model that it's your go-to model for a task.
Can we pseudocode out kind of like the core loop here? It's like for each image. I mean, I guess it's pretty clear, right? You take each image, you run the extraction, you do the math, and then you record which of the checks passed and failed. And they're all just pass fail.
Exactly. Okay. They're all just pass fail. Yeah.
Okay. Do you want to show that? Actually, this is a good idea. Do you want to show that code?
Yeah, it'd be interesting to see the code that like takes the extracted data.
It's going to be in the AI that works repo, but do you want to show the code really fast?
Sure.
Or like show one of the evals or one of the like just like the code that like takes the output and does the math on it. I mean, it's pretty simple code, I'm sure, but it'd be kind of interesting to see it for real.
So let's see. It's all zoomed in, so it's a little off. So
you have an image, you produce extracted data on it right there.
Right. So this is the extracted data.
And you have error handling to be like sometimes it fails. which is also fair. Which is also fair. Yes.
Yeah, which is actually the dashboard keeps track of how many failures there are. Which,
Got it.
spoiler alert, I tried to do Gemini 3 last night and I got a ton of extraction failures. So,
Got it.
Yeah. Not sure what's going on with that, but something to figure out.
They said this one's supposed to be better at tool calling.
I don't know. Maybe it is. Maybe I was doing something wrong. It's very possible.
No, I mean I'm sure they said that, and it's not as true as they want it to be.
Yeah.
Okay, and then you produce an evaluation result. Ah.
Right. And if we just look at, say, evaluate grand total calculation.
Cool. It's just like
and you're just doing math on a JSON object.
Mm-hmm.
Yeah. Okay. Cool. So there's nothing fancy here. You're literally just doing
nothing
math.
fancy.
Oh,
Literally.
Tolerance is interesting because you have floating point numbers. Makes sense. So you have to go build tolerance out.
Mm-hmm.
Did you have tolerance from day one, or was that something you added later when you saw some of them were like off by 1 cent?
I had this from day one.
Yeah.
Mm-hmm.
I suspect. Yeah. If you're ever doing floating point math calculations, you will always have this error. You need a tolerance. You don't have a choice.
Cool.
Yeah, it's very basic. Like I said, this task it surprised me as to how easy this task ended up being. I was expecting a lot more I was expecting to have to spend a lot more time on it.
And you know what I find really interesting about this is if you wanted to add another eval, it's actually really easy for you to add one here.
Mm-hmm.
Because you just add one more to the list. It's effectively zero cost.
That's it.
That's cool.
Yeah, that's it.
So I can see why you said this basically took you 3 hours, because you basically have two separate pipelines here. You have one pipeline that does the actual extraction. You have a separate pipeline that runs the evals on those platform on that extraction. They're both disjoint. They have no dependencies except the shared data model between them, which is the receipt data object that you showed us in the receipt.baml file. And then you have a third system that visualizes the results of the second system.
That's right.
And you just have a data contract between them that shows how to go render everything.
Mm-hmm. Yeah.
And last
time,
so
the evaluation results get written to like a JSON file right next to the extraction results.
Exactly. Yeah. I mean, if you look results, we can look at this one, detailed results. This is, if we scroll up, you see the evals. This is what the Streamlit app is reading from here.
Okay. So this is for a given receipt, for an image path. So this is how it lets you render all that stuff if you need to.
Exactly.
And then, okay.
Exactly.
Cool.
And that's how he loads data dynamically. That's how he pulls up all the information about it. Is the
extracted data embedded in here as well? In like this JSON object?
Yep,
you just have to look that up.
That was what I pasted in the whiteboard. Yeah, it's right down here. So yeah. Cool. You can just read this, and the Streamlit app has everything that it needs.
And the reason that this was so fast for you to do, Kevin, from what I understand, is last time when you built your classification system, you actually spent a lot of time on designing this shape. Like, you're like, what is the shape of this data? The extracted data has here. There's a bunch of evals that have these names and these results. And then it has to have the model information because I want to be able to compare same image on different models.
Yep.
It has to have a run information because I might run the same thing multiple times based on things that I changed along the way. So you're basically just shaping the data shape for the tooling before you actually really built it. But once you've designed the tooling, it's effectively zero work to make any different system use the same tooling.
Yeah, that's actually a really good point. I hadn't realized until you just said all that how much my work on the previous one kind of set me up for this to go really, really quickly.
Yeah, that's actually very similar to how I have seen most AI, like most companies that we've worked with have actually had a very similar response where like, I think the work up front feels so painful and so annoying because you're like, why am I doing this? I can just like one hack this, like not think about this and just do it one off. But it turns out if you do one off work, every single project takes the same amount of time consistently. Mm-hmm. But if you do the upfront work up front where you just stop and think about the design system a little bit better, the next project similarly just takes way less time because most of the fundamentals are truly the same. Now I'm curious, from the design... Oh, go ahead, Dex.
And actually, just to like echo your point, I really like this pattern. I naturally stumbled into something like this when I was building like a PII extraction and like scrubbing pipeline where like I was writing after each step of the pipeline, you want to write the JSON because then you, the human, can inspect it. You can resume from a past result. You can test incremental parts of the pipeline. Like the results actually can become like the bits that you use to build more like baked golden evals, golden data sets, golden like test sets, so that you can know that. And like having JSON is nice because it's human readable and machine readable for some people. Some people say JSON was meant for humans. I don't know if I would go that far. JSON was made for
I mean,
machines.
JSON was meant for humans. If machines are the only thing we cared about, we'd all use protobuf.
That's all right. Fair enough. Yeah. Anyways, no, I think the structure makes a ton of sense. And like, I can't imagine building any kind of AI pipeline. My question actually for both of you is like, do you have thoughts about how this would scale? Because like once you have 100,000 images, is it actually like performant to do this in JSON? Or do you have thoughts about like, would you move this to like, obviously same structure and like checkpoints along the way, but like, what are the limitations of doing it this way?
Well, I don't think JSON itself is necessarily bad. You could store it into an S3 bucket instead of JSON. It's the same thing. Like it's S3 bucket with paths. The fact that you're using a file system is the storage layer itself doesn't matter.
What
Like
if your results gets too big to like store into memory? Like you have to
Yeah,
then figure out how to like you have to do
S3.
some kind of like sharding. Yeah, but you need to pull it down to do each incremental step of the pipeline.
Sure, put it into MongoDB database then. Like put it into MongoDB database and like query only the fields that you have. Like Kevin did over here. If you scroll up, Kevin, like the JSON struct that he's storing is basically scroll up. It has a thing called evaluations. Literally, you can pull everything but the extracted data and only pull the evaluation side of it, which should be small enough. And we all know how to do like.
But I mean, if you have 500 million records, that's probably too high to be reasonable. Like that's the number of like.
Even with that, like we know how to do pagination on databases. Like
yeah,
we know
you
how
can't
to
do that
like,
in S3 though. Like I agree. Like you need those are my question is like you need something that supports like slicing and filtering and pagination, right?
S3 does that too. Like AWS has built a bunch of software on top of S3 that has all sorts of querying, pagination. I'm not saying you should use S3 necessarily. It's just like you can solve this problem as another engineering problem rather than having to think about like saying I have a bunch of data that is somewhat structured and I want to query it with some aggregation is a well-defined problem that I'm certain Claude Code could solve.
Okay, so Vibob thinks my question was boring.
Well, maybe
I can tell you though, if I had 500 million
like,
records, I would not be using a Streamlit app. No way.
No, this feels like a really good. Have either of you ever worked with Parquet? It's basically like GZIP, JSON, and S3.
This would be great for like Lance.
I'm sure
DB
people are already. Is there? Say what?
Or Lance DB or something. This would be great for that.
I don't know enough about Lance DB to comment.
Lance DB is really good for like multimodal data sets on top of it, which makes it really because it does like the one-off links to like not saving in your actual data. Now, I have one more question, Kevin. What did change in this pipeline versus your previous pipeline that you made? Were there any architectural changes you did have to make?
I think the biggest one was in the previous pipeline. We had multiple checkpoints because we had, I don't know how many people on the call were a part of that, but it was a large scale classification pipeline where the first thing we did was we dumped a bunch of categories into an embedder to filter that down. And then we took just the top however many categories and then dumped those into an LLM with the actual query. And then we get the final response. So we were able to check each one of those steps, kind of what's going in and out of each step and figure out where the problem is. Here, it's kind of just a one shot, right? There's no breakpoints or probes in order to check and see where things are kind of breaking down. It was one prompt. I guess you could kind of say with the different evals, there are all these kind of different little points, but still it's not the same, oh, I have multiple checkpoints here. I think that was probably the biggest one. Got it.
Okay. So the fact it was like structurally a different problem because you only had one checkpoint and no incremental progress along the way to measure. Mm-hmm. So you weren't analyzing multi-steps, you were analyzing one. So I'm guessing your JSON shape did change to represent that.
Definitely, yeah.
Okay.
And the last one, didn't you also have to hand label the data? Like there wasn't like an answer key for this stuff, right?
Yeah, I had to hand label the data. And last one, there was no real way to do, at least that I could think of, runtime evals.
Cool.
I remember reaching out to my family members and me and hand label the data and say it was items in a hardware store and what basically categories they should fall into in the hardware store. Another thing that's interesting about the previous problem is that the previous problem had multiple right answers. That was something that we found that was really interesting in that previous one was, like I don't remember any of the examples, but something such as, I don't know, I'm blanking, but like in air conditioning filter could be in HVAC or it could be in
air conditioning.
In air conditioning, exactly. And those could be two different categories. And so what was interesting last time is we went through the mistakes and we said, hey, these actually kind of are correct. So instead of having one answer, you have a set of right answers, and we would check to see if our output was in that set. Here, there is a right answer, right? Like they paid a certain amount for whatever, whatever they ate. So that was a different kind of way to think about it as well.
That's actually really interesting.
What did you? I was going to say, like, so what did you use this? We're getting a little short on time, and there's one good question in the chat, but like, what did you use this for? Like, did you actually take the eval and then go back and try to improve the models and switching the models? Did you change up your prompt at all?
Oh yeah.
Were you able to use this to drive improvements in the extraction? Yeah, let's look at the prompts.
Yeah, I can show you. Well, I think, so here's the prompt that's not it. You can see I played around with extracting number of transactions, but I didn't end up needing it.
As a pre-step.
Mm-hmm. Exactly.
Yeah.
Didn't end up needing it because this worked so well. I mean, this is the prompt, right? So each transaction or each item, this is what you want for each item on the receipt, and then all these receipt totals, right? And these didn't all, like, I didn't discover all these right out of the gate, right? Like we said before, rounding, discount on total, those didn't, like, I didn't have those right out of the gate. Those came from kind of iterating and experimenting.
Okay, so you iterated the data structure and the prompt together because of this thing that we do all the time on the show, which is like prompting through your output format, basically.
Right. And I mean, we can see here, if I go to, let's see, I think it is, it's this one. So if we load this, which, side note, one of the biggest improvements I made was just switching to Gemini Flash. You can see I tried GPT-4o, then Sonnet, and then Gemini 2.5 Flash. And you can see the difference it made just right there. Going from 4o to Gemini Flash almost made this, it only has one mistake. So if we look at the mistake, you can see it's here. Surprise, surprise, it has a discount of 19,000. And I mean, now the discount, the discount's here because it's part of the data model now. But before, there was no discount. And so it was missing that discount amount.
Got it.
And you can see the difference is the 19,000, which is the discount. So it's like, so that's when I saw that and I said,
you started with a small set of receipts. You figured out what can we learn about making the data model and the prompt better with that small set. Mm-hmm. And then once you got those pretty good, and you said, even if one of these is failing, right, you can basically say like, okay, that one we're not going to try to solve. Let's do a bigger data set. Let's see what other problems we hit. And so you built a tool that basically, like, when things are not passing, you can immediately dig in and use what you learned from the eval to go improve the prompt.
Exactly.
Go find the more corner cases. I love it.
You can kind of find, like, see my journey just by looking at the named runs, right? So we're here at Gemini Flash. I added just a discount on total field. And then I noticed that there's some item discounts. It's like a percentage of the item. So then I added that, and that was pretty good. So I jumped up to 50 receipts, or 51, because I forgot it started at 0, whatever.
Okay. Retry logic.
Then I added retry because I was just getting extraction failures. I'm like, fuck it, like, let's just do exponential retry. And then that worked really well.
Can we see the receipts? Can you see the results from each of those? Like the 50 and then with the retry logic?
Sure.
Like, I'd love to kind of just like see it progress over time. Just so like the high level analysis. Yeah.
Yeah.
Okay.
So here, and then if I do the retry added, you can see the unit price accuracy. Yeah, it just got even better.
Oh, sure. Yeah, because it's just like, sure, there's just some weird flakiness. Let's just like run it.
Yeah, exactly.
Cool. Okay, go on.
And then what was the next one?
The next one was same thing, but 100 And
Okay.
again, similar performance, it's doing well. And this is where you get to the point where, Vibe, this is the one we saw yesterday.
Yeah.
And this is where we start looking at the mistakes. It's like, I don't know how I would label this, right? These are the interesting ones, right? So if I come down here, I mean, we'll just look at this one, difference of 3,000. Let's see if this is an interesting
And
one
what's
or
really
not.
interesting is like clearly Kevin hasn't looked at this data on the fly. He's literally just looking at it right now, and it's like, I see something is off by 3,000.
Mm-hmm.
And like here, I can see that it literally double counted the 3,000 of the discount and the tax.
Wait, what's the discount?
Yeah.
It just added a $3,000 discount. I have no idea why.
Oh, yeah. You see that? Yeah.
I
I think
don't know
that's
why.
Well, what's also interesting is like this.
what are the 50,000 and the 17,000 underneath?
That's the cash that they paid,
Oh,
and
that's
then
in
they get
cash
tax
and
back.
change.
Yeah.
Okay.
So here
Huh.
it double counted it. Yeah, so I would probably iterate on the prompt on this one. But if we just look at a
Maybe I
couple
thought
of
it was.
others,
Yeah. Okay.
like let's see. I think this is that discount one that I got confused on. Yep, there's that.
And I think what's really important here is I want everyone on the call to really quickly realize how fast we're looking and understanding this data. The key part here is understanding the problem. And I think someone in the chat asked that important question is like, isn't this stupid? Aren't we doing manual prompting? Shouldn't we do like an optimizer? And in theory, you could use an optimizer, but the real problem is the reason that we can't use an optimizer is because real world data is messy. You can optimize if you know exactly what you're optimizing on, but we don't even know if it's correct. Like if our evals are actually correctly defined. Like in the case of earlier in the chat, we talked about like negative values. We did see correct negative values applied.
Mm-hmm.
And if we were optimizing on that failure, the prompt would be like, don't add negative values ever. But that doesn't actually mean that that's true. So while an optimizer can be useful, it's only so that it's useful once you understand the data.
Mm-hmm.
Like it will overfit for what you are telling it to optimize for. And if you don't have good definitions of the final outcome, you will lose. Like
it would be cool to take this data set and run it through a prompt optimizer and see if it can improve the eval performance. That might be a fun. We don't have time to do it today, but I thought I'd like doing like a JEPA or like doing the like BAML DSPy like Frankenstein pipeline that someone talked about.
Yeah, I think it's really important. Like fundamentally, regardless of what you use, it's really important that people look at the data. Like the tooling that you build around looking at the data, while it sounds stupid and silly and slow and arcane, this was actually the thing that'll help you speed this up. Because the real thing you want to optimize is a data set of 10,000 receipts. You don't want to optimize on a data set of 100 receipts. And if you think about it, the best example that I think is very tangible for most people is actually self-driving. So when you work in the self-driving space, there's tons of data of cars driving perfectly fine on a nice sunny day on empty highways. That data is completely useless to every self-driving car company out in the world. What I want to see is a car carrying 3 other cars on a tow truck that looks like a car headed towards your direction with a median that's completely in the middle of the road because it's broken. That is useful data. And it's the same thing in here. When I go and build the prompt optimizer, what I really want to do is I want to find the data that is relevant to then go build the optimizer on. Like that's what is a real fundamental question. Like how do you find like the most odd data sets that are actually going to help me decide this? And then you can go ahead and build what I would say is like turn this into a golden data set and say, hey, I found these weird edge cases. Let me go and define the perfect JSON for each of these data sets. Mm-hmm. This is exactly what the final output should be. And now go eval that against that for these specific, very small data sets that I have.
And I think to your point, Vaibhav, is we're doing this really quickly, right? Once you've done something like this before, right, building it again for a different system is fast. And now we're iterating through it very, very quickly. Like this whole thing, understanding the problem space a lot better, you can do in half a day or a day tops. And then you're much better equipped to do what you're saying and build your golden data set, build the right JSON, and then maybe do a prompt optimizer. But it doesn't take much time in order just to invest a little bit up front, and then you'll have that to inform the decisions you make down the road.
Yeah, it's really about I think it's really about deep understanding of the problem.
I don't know if you want to keep talking about the optimizer thing, but like there's a question in the chat is like a human won't be able to find the best prompt manually. And I
Oh yeah,
think like I want to double down on, sorry, what do you say?
I mostly agree.
Okay. It's like it's almost like it feels like it's like this perfect world framing of it where you have access to infinite data, every single potential thing that you might hit ahead of time. Then yes, like a prompt optimizer will do better. But I also think like by under optimizing, you lean into the like emergent capabilities and generative nature of these systems where it's like you don't know exactly what it's going to be capable of. And you're better off prompting less and less specifically and having a good feedback loop
Well,
like we've built here.
you know what I would do here is like, let's say I was shipping this in a product for actually making
Yeah.
this like for like auto ingesting receipts on like
Yeah.
Brex or like banking app or like any sort of like FinOps application, like Concur or any sort of like receipt management system. What I would do is I would go ahead, if you look at the top level data set, can you go up, Kevin?
Uh,
Yeah. Like let's say I'm filing like a reimbursement for my company analysis.
oh, yeah, this one.
What
Yeah.
I would see here is like, look, what I want to ask myself is I want to ship a product. I don't actually care about hitting 100%. Here's what I care about. I care about the user's problem being solved. The user's problem
Yep.
here is entering receipt data is freaking annoying and really hard.
Mhm.
So here's what I would do. I would look at this data and be like, okay, cool. We're hitting a really high percentage success rate. Like it's mostly correct. What's the exact percentage here?
Yeah.
Do you know what it is, Kevin? If you scroll up over grand total.
Yeah. If you can save me having to enter in a
97.
receipt,
3% failure rate. Like I'm at a 3% failure rate. 99% of the over 95% of the time, I won't have to enter the receipt. What I would say is, great, I will ship this app, but because I have all these guarantees built into it, what I will do secondarily is into my UI UX, I will build a system that says something else, which is I will say I will flag that for the user and say, I found a mistake. Can you please double check every single entry manually? And I would literally force them to check every single thing in the UI to make sure they actually validate it against the actual receipt. And now I have a system that's 100% correct.
and yeah, it's about bridging that gap with human in the loop, right? It's like as long if you're saving me, if I only have to do that 1 in 20 receipts, you're still saving me a shit ton of time because without the system, I would have to do every single one of them.
Not only that, you would have had to manually enter it versus checking for accuracy. Huge difference.
Yeah.
And only checking the ones that fail my checks,
Yeah.
which is also a huge different shift. So like the burden just went from like uploading receipts being like a painful task that takes like a couple minutes to being something that takes 90% of the time, 1 or 2 seconds, and then 10% of the time takes like 30 more seconds on top of that. So my burden is way less. But I could go even further. What I could do, we could build a second system here that says the LLM is actually going to be wrong. We'll assume that the model will be wrong. And then we'll build a second system on top of it that says whenever we get a grand total calculation error, we'll actually tell the model, hey, your error is wrong. Your grand total is completely wrong. Here's how much it's off by. Update the original data model to produce. Here's the original data model. Here's the error that you have. Re-update it to go do that. And now I can run the grand total calculation again off of that error. So not only building in the runtime checks as like a thing I'm doing for evals, but actually building into the product and saying when
As
it's
a
wrong.
just like self-correcting, like, hey, retry because there's an issue with this kind of thing, and not even sending it to the human.
And then and I let that run up to 3 times, and if that fails the 3rd time, I send it to the human. Or I might even show the human the UI and let the human know, hey, I found an error. I'm working on fixing it. Give me like a second, and I'll fix it. And the human can basically then either review or not fix it. It's up to them. And that's kind of like a few other things that you can do here. And I think it's more about understand that evals are not purely about like offline evals, but how you can make them be online evals so that you don't have to prompt optimize and end up with the perfect prompt. Because if you can only ship your product when it's perfect, you will lose the battle of shipping this product.
Yeah.
Yes. That's a great takeaway.
Yeah.
Kevin, if you had one piece of advice to someone who wanted to build a system like this, like what's the 1 or 2 biggest takeaways from your side?
Gemini. So the first one's Gemini Flash is seems to be the best at OCR. So like notably better than Sonnet or 4.0. So just going from 4.0 right here, same prompt, same data model, everything, to Flash right away,
That's
noticeably
cool.
better. Yeah. So that was the biggest thing that surprised me. And the second one, I mean, we've said it before, but it's you got to look at your data. You won't. I mean, maybe to some people, the rounding, the discounts, the different taxes, maybe that would be obvious to some people, but particularly the discounts and the rounding weren't obvious to me. Even even after I looked at some of the receipts initially, I still missed it. I didn't check 100, right? And so it took building this out and then looking at the errors and seeing like, okay, I understand what the error this is making, and this is obviously going to be present in a lot of receipts because these receipts just tend to have, this data tends to have this feature. So it's looking at your data, and there's no real magic way around that I found. You have to understand the problem.
And what's really interesting about that is like changing the shape of your data isn't just like changing the prompt. It's actually about changing like the data model that your code is using around the system.
Okay. Question for you guys. Knowing what you know now, and you don't have to name any names, but there's a lot of companies out there selling evals, either selling the problem of you must be doing evals or selling products that help you do evals so you can improve your stuff. What do you think about evals as a business?
I think obviously everyone wants to make money doing something. So it's not like it's not valuable, but I think it's very similar to how front end works. You don't really buy front end. You can buy someone to build your front end. You can buy someone to host your front end, but you don't buy your UI components typically. Your UI components are yours and your business's. I think eval is very similar. You got to design the eval. Like the metric itself, anyone that's telling you is selling you a metric is scamming you because the metric is so domain specific, so problem specific that it doesn't really matter. And then everything else is just like harnesses to run stuff.
That's
So
what
if you're
Josh you
gonna,
just said.
oh yeah,
Aren't
exactly.
existing eval solutions mostly harnesses to run? I mean, I remember when Brian came on and he was talking about their decaying resolution memory and he was showing some of their code and he was like, hey, are you okay sharing kind of some of your closed source stuff? He's like, yeah, I can show you guys the code. That's okay. I will never show you guys the evals. The evals are the thing we keep super tight. And it's like, okay, yeah, that's actually the hard work of building the product is like developing over time the same way he didn't want to outsource his memory system. He didn't want to outsource his eval system because it was really, really tailored to his product and his problems and his users.
Yeah, and I'm not saying there's not value in paying someone to run your evals for you. But I'm also not saying there's like a necessary need and an urgent need to go do that either. Like in my opinion, like what Kevin just did over here, so was like clearly it didn't take him that long. It did take him some design time and some system design time. And I guess if people use his source code and point Claude Code at this repo and say, hey, design me an eval system works kind of like this, or like chat with look at this code and help me think about how to design evals for my own system, like what design system I can use there. I'm certain they could do it in maybe not 3 hours, but probably not 1 week either. It's probably like a 1 day process to go design this out. And like my thought process is like, just do that. And then if you decide that, hey, we're running evals on 500 million data sets and we need to run like an offloaded distributed system and we don't want to own that, great. Go pay for that. If you're running like 500 receipts, just run on your stupid machine. Like it's like async IO is not going to break on your system. If you want to have a shared distributed system that everyone can see these results and you don't want to go build that for your team, then just go do that. It's not going to take you that long to go do that, but also pay someone for that. That's not a bad thing to have. Like building out this versioning system, if someone has designed it in a way that is really beautiful and good, like Vercel has done a great job at shipping front-end UIs with staging environments, on pull requests, like all that stuff is really, really good in Vercel.
It has nothing to do with writing front-end code, but it makes writing front-end code better.
Exactly. And you can build your own system for that, but like I don't want to. I don't want to say like for a PR launch this preview URL.
We built our own at Sprout. It was big. It was incredibly valuable though. Like it was the most useful part of the dev platform at the whole company.
Yeah. But it's so much better to just pay someone for it. And I think that's kind of what it comes down to is like you got to pick the parts of your eval system that are actually useful. If you don't have like 100 people looking at random evals results all the time, then you probably don't need this. I would just go ahead and straight just like host it and just send over like a tail scale URL to your teammate and go do that. Produce a bunch of JSON files that you can share over some like check them into Git if you want. It doesn't really matter. And I think it's just about designing the system you want. And like paying for it, I think can be useful, but it also isn't like a necessary thing that you have to do. Evals are necessary. Paying for them are not.
Amazing. This was super fun. Kevin, thank you so much for jumping on and sharing.
Absolutely.
I can't wait to. Seems like about every 6 weeks you've gone and changed the rules of the game. So hope to have you back again soon. This is great. Bob, any last thoughts?
All the code is already on GitHub, I guess.
I haven't pushed it yet, but I'll do that.
Push it, make the PR. We'll merge it in. I guess for everyone else that's still listening, this is AI That Works. If you guys are interested in this kind of concepts and you like seeing this kind of content, come check out the subscription over here or check out the YouTube. We'll usually post the videos 1 week afterwards. Really appreciate this time with Dex and obviously Kevin for making up the time. It's been always a wild ride. And thank you everyone for joining the chat as well.
Yeah. Thanks.
Thanks, everybody.
Bye, everyone.